Good morning, my dear students. Today we are going to discuss some of the important numericals on electric potential and capacitance. Okay. In our previous videos, we have discussed some of the important concepts of the same chapter. Okay, you may have a look on those concepts by watching my previous videos. Okay, and please do remember, my dear students, in your final theory examination, one 5-mark numerical will be there from a unit electrostatics. Okay, electrostatics has two chapters, that is electric charges and fields and electric potential and capacitance. Okay, from these two chapters, one 5-mark numerical will be there in your final theory examination. Okay, so therefore we shall have a look on some of the most frequently asked numericals of electric potential and capacitance. Okay, this is our first numerical. Let us have a look. This numerical has two parts, part A and part B. In part A, they have asked to calculate the potential at a point P due to a charge of 4 into 10 to the power minus 7 coulomb located 9 centimeter away from the point. Okay, and B point is find the work done in bringing a charge 2 into 10 to the power minus 9 coulomb from infinity to that point. Okay, the charge 2 into 10 to the power minus 9 coulomb is taken from infinity and placed at that point at which we are interested to calculate electric potential. In the first part only we calculate electric potential, and part B contain one more question: does this work depend on the path along which charge is brought? Okay, so let us start with the first point, that is A, solution. Okay, so first we shall write the given data, and that is charge they have given. Charge Q is equal to, actually it is source charge, Q is equal to 4 into 10 to the power minus 7 coulomb located 9 centimeter away from the point. Okay, point P, or you can call it as distance. Distance R is equal to 9 into 10 to the power minus 2 meter. Actually 9 centimeter is there. When you convert it into meter, 10 to the power minus 2 comes. Okay, so this problem looks like this is source charge and this is R distance. Okay, at this point, let us call it as point P. At this point P, we are supposed to calculate electric potential, and as we know formula, V is equal to 1 divided by 4 pi epsilon naught Q divided by R, where Q is the source charge and R is distance. Distance from the source charge, okay, at which we are interested to calculate electric potential. Okay, so see here, 1 divided by 4 pi epsilon naught is 9 into 10 to the power 9. Okay, and Q they have given 4 into 10 to the power minus 7 divided by R distance is there, and R distance is 9 into 10 to the power minus 2. So 9 is cancelled, 9 and 7, it is 2, 2 plus 2, it is 4. So it is 4 into 10 to the power 4. That is V is equal to 4 into 10 to the power 4 volt. The unit of electric potential is volt. Okay, so this is the formula. And the second part, this is part A actually, and part B. In part B they have asked to calculate work done. They have brought a charge 2 into 10 to the power minus 9 coulomb from infinity and they have placed at point P. Okay, I will draw here. Say this point is infinity. From infinity, 2 into 10 to the power minus 9 coulomb charge is taken, and that charge is placed at point P. Okay, and as we know, at point P, the electric potential due to this charge is how much? It is 4 into 10 to the power 4 volt. Okay, and they have asked to calculate work done. Therefore, work done formula is work done in bringing a charge from infinity to that point P is equal to Q into V, where Q is what? It is charge. Okay, actually in formula it is a test charge, and V is what? Potential. Potential we have calculated, it is 4 into 10 to the power 4. Therefore Q is how much? It is 2 into 10 to the power minus 9, and voltage, that is electric potential, 4 into 10 to the power 4. Therefore, it is 2 4s are 8 into 10 to the power minus 5. Okay. Therefore, work done from infinity to point P is how much? 8 into 10 to the power minus 5 joules. Okay. And does this work depend on the path along which charge is brought? Okay. It is no, because work done is conservative. Therefore, conservative force does not depend on path followed. Okay. Therefore, the answer for this is no. Okay. Yes, students, this is our second numerical. Have a look. Two charges 4 into 10 to the power minus 9 coulomb and minus 3 into 10 to the power minus 9 coulomb are located 0.1 meter apart. At what point on the line joining the two charges is electric potential 0? Take potential at infinity to be 0. This is given data. Okay. So in this numerical, they have given two charges, and those two charges are separated by 0.1 meter distance. Okay. So let us consider a charge A and another charge B. Okay. A charge, the magnitude they have given, it is 4 into 10 to the power minus 9 coulomb. And B charge also they have given, it is minus 3 into 10 to the power minus 9 coulomb. And these two charges are separated by a distance of 0.1 meter apart. Okay. So please do remember, my dear students, one charge is positive, another charge is negative. Okay. Therefore, the magnitude of the net charge or net electric potential in between somewhere it is going to be 0. Okay. And that point we are supposed to calculate in this numerical. Okay. So let us begin. Before that, we shall consider a point. Say it is, this point is O. At point O, the potential due to A charge and potential due to B charge is equal, or the sum of potential due to A and potential due to B at O is equal to be 0. We shall consider like that. And this point O is located at a distance of x. Okay. And if this distance is x, then certainly this distance is going to be 0.1 minus x. Okay. So remember, AO is equal to x and BO is equal to 0.1 minus x. Okay. So first we shall calculate potential at O due to A charge. Potential at O due to A, that is VA is equal to 1 divided by 4 pi epsilon naught Q divided by R. This is the formula, and 1 by 4 pi epsilon naught is 9 into 10 to the power 9, and Q value is how much? It is 4 into 10 to the power minus 9 divided by R distance. R distance means this distance, it is x. So 9 is cancel, 9 4s are 36 divided by x. This is VA. Okay. And now VB, potential at O due to B. Okay. Once again, VB is equal to 1 divided by 4 pi epsilon naught Q divided by R. This is potential due to point charge formula. And VB is equal to 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Q value, it is minus 3. Polarity we are supposed to write. With sign we are supposed to write. So minus 3 into 10 to the power minus 9 divided by R distance. R distance means this distance. This distance is how much? 0.1 minus x. Okay. So once again 10 to the power minus 9 cancel. 9 3s are 27. So minus 27 divided by 0.1 minus x. This is VB. Okay. And now potential at point O due to A and potential at point O due to B. The sum must be equal, then and then only potential at O is going to be 0. Okay. VA plus VB is equal to 0. This is the condition, then and then only at potential at O is going to be 0. VA is how much? 36 divided by x. And VB minus 27 divided by 0.1 minus x equal to 0. Or 36 divided by x is equal to 27 divided by 0.1 minus x. We are supposed to solve this. I will wash this. see here, 36 0.1 minus x is equal to 27x, and 36 it is a 3.6, 36 into 0.1, and 36x is equal to 27x. So 36x plus 27x is equal to 3.6, and it is 63x is equal to 3.6, or x is equal to, when you solve this, it is going to be 3.6 divided by 63 is equal to 0.057 meter. Okay, it means at a distance of 0.057 meter from point A, okay, the electric potential due to point A and point B is going to be 0. The sum is going to be 0. This is our next numerical, third numerical. 8 charged water droplets, each with a radius of 1 mm and a charge of 10 to the power minus 9 coulomb, coalesce to form a single drop. Calculate the potential of the bigger drop. Okay, so this is also a easy numerical, so please watch carefully. 8 charged water droplets are there. 8 charged water droplets, they coalesce to form a bigger water drop. Okay, like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are water droplets. Okay, and all these 8 water droplets, they have coalesced to form a single drop. Now this is a single drop. Okay, bigger drop. And each single drop, okay, each single drop has a charge. How much? It is 1 or 10 to the power minus 9 coulomb, or 1 into 10 to the power minus 9 coulomb. So here 8 charges are there. 8 charges or 8 water droplets. 8 water droplets have charge. So it is 8 into 10 to the power minus 9. One water droplet has 10 to the power minus 9 coulomb, and 8 water droplet will have 8 into 10 to the power minus 9 coulomb charge. Okay, and remember, volume of this bigger drop must be equal to volume of all these 8 water droplets, right? Volume of 8 water droplets must be equal to volume of bigger water drop. Okay, single drop. This is volume. Okay, one single bigger drop, and volume of each individual water droplets, okay, they must be equal. Okay, and volume of 8 water droplets, it is consider the radius. Small water droplet has radius how much? It is 1 mm. Okay, in this case we shall consider it as 4 by 3 pi r cube, where r is what? Radius of small water droplets. It is actually 1 water droplet, but how many water droplets are there? 8 water droplets are there. Therefore I will write 8 multiplied by 1 water droplet volume. Okay, now it is going to be 8 water droplets volume, and this must be equal to volume of bigger water drop. And consider the bigger water drop has a radius of r, capital R. Okay, and now it is going to be 4 by 3 pi r cube. Okay, so here 4 by 3 pi is going to be cancelled. So 8 r cube is equal to r cube, or I can write it as 2r cube is equal to r cube. So r is equal to 2r. Okay, so here r is equal to 2. Small r value they have given, it is 1 mm. Therefore it is 1 into 10 to the power minus 3. Milli means 10 to the power minus 3. Therefore it is 2 into 10 to the power minus 3 meter, or 2 mm. R is equal to 2 mm. Okay. Now we are supposed to calculate the potential of the bigger drop. Okay. So potential formula, as we know, potential formula is V is equal to 1 divided by 4 pi epsilon naught Q divided by R. Okay. And 1 divided by 4 pi epsilon naught is 9 into 10 to the power 9. Q value they have given 8 charged water droplets, each with a radius of 1 mm and a charge of 10 to the power minus 9 coulomb. One water droplet has a charge 10 to the power minus 9 coulomb. Therefore 8 charges are there. Therefore it is 8 into 10 to the power minus 9 charge coulomb. And our distance, it is 2 into 10 to the power minus 3. Okay. So 10 to the power 9, 10 to the power 9 cancel. 2 1s are, 2 4s are, 9 4s are, it is 36. Therefore it is 36 into 10 to the power plus 3. Okay. Volt. This is the potential. Potential due to bigger drop is how much? 36 into 10 to the power 3 volt. Okay. So please note. Students, this is our next numerical. See here, calculate equivalent capacitance of the combination shown in the given figure. Okay, so two circuits have been given. Okay, and these two combinations we are supposed to calculate equivalent capacitance. As we know, the series formula, capacitance in series. Okay, 1 divided by Cs is equal to 1 by C1 plus 1 by C2. If two capacitors are there, then 1 by C1 plus 1 by C2. If n number of capacitors are there, it is up to 1 divided by Cn. Okay. And for parallel plate capacitance, I mean capacitors connected in parallel, Cp is equal to C1 plus C2 plus C3 plus so on up to Cn. This is equivalent capacitance if capacitors are connected in series, and this is equivalent capacitance if capacitors are connected in parallel. Okay, and see, this combination has both series as well as parallel combination, and even this combination also. Okay, and we shall apply series as well as parallel formula here. See here, this 5 microfarad and 10 microfarad, these two capacitors are in series. Okay, and this 3 microfarad capacitor is in parallel with these two capacitors, right? So first we shall apply parallel series formula for these two capacitors. Let us call it as C1 and it as C2 and it as C3. Okay, C1 and C2 are in series. Okay, see here, one plate of the first capacitor is connected to another plate of second capacitor, right? Therefore these two are in series. So it is 1 divided by Cs is equal to 1 by C1 plus 1 by C2, or Cs is equal to C1 C2 divided by C1 plus C2. C1 is how much? 5, and C2 is 10 divided by C1 plus C2, 5 plus 10, 15. So 5 1s are, 5 3s are, it is 10 divided by 3. Okay, microfarad. Okay, so see here, I will redraw this circuit here. Okay, now these are the terminals. Now this capacitor value is how much? 10 divided by 3, and this capacitor value, it is 3. See here, 10 divided by 3 and this 3, these two are in parallel combination. Therefore parallel formula, Cp is equal to this Cs plus it is C3. So Cs is 10 divided by 3 and C3 is 3. Okay, so it is so 10 plus 9 divided by 3, that is 19 divided by 3 microfarad. Okay, so instead of these three many capacitors, we can connect to only one capacitor like this. Okay, and this capacitor value should be 19 divided by 3 microfarad, or 3 1s are 3 6s are 6.3 microfarad. Instead of connecting three capacitors 5, 10, 3, we can connect only one capacitor, and that capacitor value should be 6.3 microfarad. Understood? So note down. So now let us solve second B part. Okay, I will wash this. See here, once again this 4.5 microfarad and 4.5 microfarad, these two are connected in parallel. Okay, and this parallel combination is in series with 3 microfarad and 3 microfarad. Understood? See, let us call it as C1, it as C2, this is C3 and C4. C2 and C3 are in parallel with C1 and C4, right? So first apply parallel combination formula, C2 and C3 in parallel. Therefore, let us call it as C5. C5 is equal to C2 plus C3, and C2 is how much? 4.5 plus C3 is also 4.5. 4.5 plus 4.5 is, it is 9. Sorry. Okay, 9 microfarad. C5. Okay. So I will redraw this combination. Okay. So now this is C1, this is C5, and this is C4. C1 value is how much? 3 microfarad, and C5 it is 9 microfarad, and this is C4. C4 is 3 microfarad. Now these three are connected in series, and series formula 1 divided by CS is equal to 1 by C1, 1 by C2, 1 by C3. 3 capacitors are there, therefore up to C3 I am supposed to write. So 1 by CS is equal to 1 by C1. It is not C2, it is C5, and this is C4. Okay, according to this formula. C1 value is how much? 3, and C5 value is how much? 9, and C4 value is how much? It is 3. Okay, so 1 by CS is equal to 2 by 3 plus 1 by 9, or CS is equal to 3 into 9 divided by okay, 3 into 9 divided by 18 plus 3. Okay, so 9 3s are 27 divided by 18 plus it is 21. So 3 9s are 3 7s are. So CS is equal to 9 by 7 microfarad. Okay, so this is equivalent capacitance of this combination. Instead of connecting 3, 4.5, 4.5, 3, 4 capacitors are there having certain values. Instead of connecting these many capacitors, we can connect only one capacitor having value 9 divided by 7 microfarad. Okay, dear students, this is our next numerical, fifth numerical. Have a look. When two capacitors of capacitance C1 and C2 are connected in series, the net capacitance is 4 by 3 microfarad. When connected in parallel, its value is 6 microfarad. Calculate C1 and C2. Okay, a very simple and interesting numerical. Okay, we are supposed to find out the values of C1 and C2. They have given net capacitance. Okay, see here, solution. Two capacitors C1 are connected in series, the net capacitance. This is series capacitance and this is parallel capacitance. As we know, if capacitors are connected in parallel, then the equivalent capacitance is going to be C1 plus C2, and its value is 6 microfarad. Okay, and if these two capacitors are connected in series, the formula is going to be CS 1 divided by CS is equal to 1 by C1 plus 1 by C2, or CS is equal to C1 C2 divided by C1 plus C2 is equal to 4 divided by 3 microfarad. Okay, so C1 C2 is equal to 4 by 3 into C1 plus C2, and C1 plus C2 we know, let us call it as equation 1. So C1 C2 is equal to 4 by 3 into C1 plus C2 value is how much? It is 6. 3 1s are 3 2s are, so 4 2s are 8 microfarad. This is value of C1 and C2. Let us call it as equation 2. Okay, so now C1 plus C2 is equal to 6 microfarad we know, and C1 C2 is equal to 8 microfarad we know. Okay, so to solve in a very easy method, we shall make an arrangement like this. See here, C1 minus C2 square is equal to C1 plus C2 square minus 4C1 C2. Okay, I have just arranged the terms. If you square this C1 minus C2, square this, that value is going to be equal to this value. Okay, as you can observe here, C1 square plus C2 square minus 2C1 C2 is equal to C1 square plus C2 square plus 2C1 C2 minus 4C1 C2. 2C1 C2, 4C1 C2, it is going to be C1 square plus C2 square minus 2C1 C2. Okay, it means LHS, RHS both are equal. Therefore, this arrangement is correct. Okay. Okay, so C1 minus C2 square is equal to C1 plus C2 value is how much? It is 6. So it is 6 square minus 4. C1 C2 value is how much? It is 8. So 6 square is 36 minus 8 4s are 32. So it is going to be 4, right? C1 minus C2 is square is equal to 4. Therefore, C1 minus C2 is equal to 2. Let us call it as equation 3. Okay. So see here, C1 plus C2 is equal to 6 microfarad is there. C1 minus C2 is equal to 2 is there. Therefore, solving 1 and 3. Solving 1 and 3. Okay. So C1 plus C2 plus C1 minus C2 is equal to 6 plus 2. I have added here. C2 get cancels. So C1 plus C1, 2C1 is equal to 6 plus 2 is 8. Therefore, C1 is equal to 4 microfarad. Now I got C1 value. Okay. Similarly, if I substitute the value of C1 in equation 1 or equation 3, I am going to get the value of C2. See here. C1 is 4. Okay. So 4 plus C2 is equal to 6. I will write here 4 plus C2 is equal to 6. C2 is equal to 6 minus 4, or it is 2 C2 microfarad. So this way easily we can solve such numericals. So where C1 value is 4 microfarad and C2 value is 2 microfarad. Okay. And yeah, as you can cross check here, C1 plus C2 is equal to 6 is there. C1 value is 4 and C2 value is 2. 4 plus 2 is 6. Okay. So this is our next numerical. Have a look, my dear students. A 400 picofarad capacitor charged by a 100 volt DC supply is disconnected from the supply and connected to another uncharged 400 picofarad capacitor. Calculate loss of energy. First, the capacitor is charged by 100 volt DC supply. Then the capacitor is disconnected and connected to uncharged capacitor. So always remember, whenever a charged body is connected to uncharged body, half of the charge will flow to the uncharged body. Okay, that is the concept. Okay, so first we shall calculate the total energy of the charged body. Okay, so let us call it as U1. U1 is equal to 1 by 2 CV square. Okay, actually this is the formula for energy stored in capacitor. One more formula is there, 1 by 2 QV. Okay, where Q is equal to what? It is C into V, and VV it is V square. Okay, so 1 by 2, C value is how much? 400. So 400, pico is there, pico means 10 to the power minus 12, and V square is 100. 100 into 100, it is 10 to the power 4, right? So 2 ones are 200s are. So it is 200 into 10 to the power minus 8 or 2 into 10 to the power minus 6. Energy is there, therefore it is joules. It is U1. Okay, so this is energy stored in charged capacitor. Now this charged capacitor is disconnected and it is reconnected to what? Uncharged capacitor having a magnitude of 400 into 400 picofarad. Okay, so see here, that is U2, let us call it as U2 is equal to 1 by 2 Q dash V. Okay, where Q dash is what? Charged. Okay, when the charged body is connected to uncharged body, the charges will flow, half of the charges will flow. For example, this is uncharged charged body. Okay, this charged body has charge Q. Now this charged body is connected to uncharged body. Uncharged body. Okay, the moment we connect uncharged body to a charged body, half of the charge will flow. For example, here 10 charges are there, 5 charges will go and settle on uncharged body and 5 charge will remain on charged body. Okay, if 10 charges are there, okay, like this is what happens. If Q charges are there, then Q by 2 will happen. Okay, Q by 2 will locate on charged body and Q by 2 will locate on uncharged body. Uncharged body will become charged body now. Okay, so therefore it is Q dash by V, and Q dash value is how much? It is Q by 2. Okay, into V. So 1 by 2 Q by 2 V. Q by 2 V, it is what? U1. Therefore it is U1. So U1 we have calculated. It is 2 into 10 to the power minus 6. So 2 cancels. So U2 is equal to how much? 1 into 10 to the power minus 6 joules. Okay, and loss of energy is equal to U1 minus U2. U1 is 2 into 10 to the power minus 6, U2 is 1 into 10 to the power minus 6, therefore it is 1 into 10 to the power minus 6 joule is loss. Okay, so this amount of energy is lost when a charged body is connected to uncharged body.